Assalamu alaikum students. I hope you all are good. Today we are going to learn some basic concepts and then we will learn the theorems related to these concepts. The first concept which we are going to learn here is transversal. In the given figure, line N called transversal. In this figure, this line N, that is called the transversal. It intersects two parallel lines, L and M. These two are the parallel lines and a line N intersects them at point P and Q. The point where line N intersects line L is called P and this point is called Q. And we have 8 angles total formed here, 4 on point P and 4 angles on point Q. So the line that intersect these two parallel lines is called the transversal. Now among these 8 angles, some of them are interior angles and some of them are exterior angles. To check which one of them are interior and which one of them are exterior, what will we do? For example, if we consider angle 4, this one, let us draw the arms of this angle. This is the first arm and this is the second arm. These are the arms of angle 4. We can see that both points P and point Q lies on angle 4. Both point P and Q lies on angle 4. For example, point P is here, we have point P here and we have point Q here. Both the points P and Q lies on the arm of angle 4. So angle 4 is called interior angle. Okay, if both the point of intersections lie on the arm of an angle, such arm is called interior angle. So angle 4 is an interior angle. Let us draw another angle. For example, we have taken angle 3, this one. If we draw its arm, this and this, we can see this is our angle 3. We can see both the points of intersection, point P and point Q, lies on the arms. Here we have point P and here we have point Q. Both the point of intersections lie on the arm of the angle. It means that angle is called interior angle. So angle 3 is also an interior angle, this one. Similarly, if we draw arms of this angle, it will include this line and this line. These two will be the arms of angle 5. And we can see that on this arm, we have point Q and point P, both the points. It means angle 5 is also an interior angle. Similarly, angle 6 is an interior angle. Now if we take angle 1, let us draw its arms. If we draw the arms of angle 1, we will have this line and this line. Here we can see that only one point is included in this angle. Only one point is included in this angle and that is point P. If only one point is included in the angle, such angles are called interior angle. If both the point of intersection lies on the arm of the angle, then such angle is called exterior angle. Similarly, we have 4 exterior angle. Angle number 1, angle number 2, angle number 7 and angle number 8. These 4 are the exterior angle and these 4, 3, 4, 5 and 6. These 4 are the interior angles. Next we have the concept of alternate angles. Such pair of interior angles. It means alternate angles are interior angles. Such pairs of interior angle. Interior angles means we can select alternate angles only from angle 3, 4, 5 and 6. Okay, such pair of interior angles which have different vertices. If I consider this 4, then its alternate angles, its alternate angle will be selected from 5 and 6 because 3 have the same vertex and 5 and 6 have the different vertex. So according to first condition, such interior angles that have different vertices, if I consider angle 4, then its alternate angle will be from 5 and 6, or if I consider angle number 3, its interior angle will be from 5 and 6. So if I have considered angle number 4, so let us check the second property. Their interiors lie on opposite side of transversal. We have chosen angle number 4 and we are finding its alternate angle. 3 is not the option because it has the same vertex. We have two options, angle number 5 or angle number 6. Now according to second condition says the angles should have interiors on opposite side of transversal. So 4 is on left side. So its alternate angle will be on the right side. It means the alternate angle of angle 4 is angle number 6. Similarly, alternate angle of angle number 3 is angle number 5. You can also find alternate angle by drawing an alphabet Z. The Z may be rightward or leftward. This is Z, it means this and this. These two are the pair of alternate angles. This one and this one. These two are alternate angles. Similarly, if we draw Z like this, a Z may be a rightward or leftward. A Z can be drawn like this. Now the pair of alternate angles is 3 and 5. It means 3 and 5 is a pair of alternate angles. We have two pairs of alternate angle here, angle number 3 and angle number 5. Similarly, angle number 4 and angle number 6. Next, we have corresponding angles. To find a pair of corresponding angles, these are the conditions that have different vertices. If I consider angle number 1, then its corresponding angle will be from these four angles 5, 6 and 7, 8 because 1, 2, 3, 4 have the same vertex. If I select 1, its corresponding angle will lie at vertex Q because according to the definition corresponding angles must have different vertices. The second condition, have their interiors on the same side. If I consider angle 1 and I am looking for its corresponding angle, then I have these four choices. Now according to the second condition, corresponding angles have their interiors on same side. It means we cannot take 6 and 7 because they have interiors on the opposite side. So when looking for corresponding angle of angle number 1, we are left with two choices, angle number 5 and angle number 8. Now the third condition consists of an interior angle and the other exterior angle. If we are looking for corresponding angle for angle number 1 is an exterior angle. Its corresponding angle will be an interior angle because it itself is an exterior angle. So its corresponding angle will be an interior angle. So from 5 and 8, 5 is an interior angle. It means the interior angle of angle number 1 is angle number 5. Similarly, if we consider angle number 2, according to first property, corresponding angle will not have same vertex. We have four choices, angle number 5, 6, 7 and 8. According to second condition, their interior should be on same side. We are left with only two choices, 6 and 7, because 5 and 8 have interiors on the opposite side. And according to the definition, interiors should be on the same side. So when looking for the interior corresponding angle of angle number 2, we are left with two choices, angle number 6 or angle number 7. Now according to the third condition, if one angle is an interior angle, then its corresponding angle will be an exterior angle. If the angle is an exterior angle, its corresponding angle will be an interior angle. So from these two, 6 and 7, angle number 6 and 7, we can see that angle number 7 is an exterior angle and angle number 6 is an interior angle. So the pair of corresponding angles are angle number 2 and angle number 6. Similarly, when looking for all corresponding angle of angle number 4, we have two choices, 5 and 8. Between 5 and 8, angle number 5 is interior angle and angle number 8 is exterior angle. Angle number 4 is interior, so its corresponding angle will be angle number 8. Similarly, corresponding angle of angle 3 is angle 7. Angle 2 has corresponding angle number 6, and angle number 1 has exterior angle, corresponding angle number 5. Also, we have a trick. If you want to find corresponding angle, what we can do? We can make F like this, straight line, transversal, and the second straight line. Okay, now moving forward. Parallel line. If two lines are said to be parallel if they are coplanar. The first condition, they should lie on the same plane. Second condition, they do not intersect. They must not intersect each other. If two lines do not intersect each other, they are called parallel lines, and they are denoted by this symbol, two straight lines. Now parallel line postulate. Through a point outside a line, only one line can be drawn parallel to the given line. If we have a line and we have a point outside the line, if we have a line, for example, we have chosen a line here and we have a point here. So from this point that is outside the line, we can draw one and only one parallel line. It means only one parallel line can be drawn from this point. Okay, that is the parallel line postulate. This parallel line postulate can also be written as both of the two intersecting lines cannot be parallel to the same line. If we have two intersecting lines like this, we cannot have another line which is parallel to both of the intersecting lines. If we can have a line that is parallel to any one of them, but we cannot have a line which is parallel to both the intersecting lines. This is called Playfair axiom. Now we have theorem number 3. If a transversal intersects two coplanar lines, we have two coplanar lines. Coplanar lines means lines that lie on a same plane. And a transversal intersect them. We have learned what is a transversal. Such that the pair of alternate angles are congruent. Then the lines are parallel. Now we have two coplanar lines and a transversal intersect them, and it is given that the pair of alternate angles are congruent. Angle number 1 and angle number 2 is a pair of alternate angle. We have to prove that the lines are parallel. So we will write the given statement. Two lines are given to us. So we have written AB and CD are two coplanar lines, and transversal EF, this one, cuts them at point P and Q. This transversal cuts them at point P, this is point P, and Q, this is point Q, respectively, such that angle number 1 and angle number 2 are congruent. 1 and 2 are alternate angles. This is given to us. We need to prove that the lines are parallel. So, to prove that, line AB is parallel to line CD. Now we will consider it by assuming that if AB and CD are not parallel, we have to prove that the lines are parallel, but we have considered its opposite situation. We have considered its opposite situation. We have to prove that the lines are parallel, but we have supposed that the lines are not parallel. If lines are not parallel, then they must be intersecting. We have only two options if the lines are parallel. Either the lines are parallel or the lines are intersecting. So we have considered that the lines are not parallel. It means they are intersecting. So then being coplanar, they will meet at point, say at R. They are coplanar lines and they are not parallel. It means they are intersecting lines. So if the lines are not parallel, we have considered the lines are not parallel, it means they are intersecting and they will intersect at point R. Our diagram will be somewhat like this. The lines are not parallel. These are the lines. If the lines are not parallel, they will intersect at point R. Here we can see that we have a triangle. A triangle is drawn here. And PQR will be a triangle, look like figure number 2, this one. Now we have to prove. We are considering the triangle. In triangle PQR, this one. In triangle PQR, angle number 1 is exterior angle, this one. Angle number 1 is exterior angle of a triangle. Okay. We have learned what is an exterior angle of a triangle. When we extend any side of a triangle, then the angle formed between the extended side and the side of the triangle, like this one, this is called the exterior angle. Now in the triangle PQR, angle number 1 is the exterior angle, and angle number this one 2, this was angle number 2, this one, angle number 2 is its interior angle. Interior opposite angle, angle number 2 is its interior opposite angle. Okay, in triangle PQR, angle number 1 is exterior angle and angle number 2 is interior opposite angle by definition. Statement number 2, therefore angle number 1 will be greater than angle number 2 because this is an exterior angle of a triangle and this is its interior opposite angle. According to theorem number 2, we have learned that exterior angle is greater than interior opposite angle. If one is exterior angle, angle number 2 is its interior opposite angle, it means angle number 1 is greater. So this is the statement, angle number 1 is greater than angle number 2 by theorem number 2. We have proved this in theorem number 2. But angle number 1 is equals to angle number 2. But in the question it is given that angle number 1 and angle number 2 are equal. So our third statement is angle number 1 is equals to angle number 2, which is the reason that it is given. Now we can see that we have two statements. Statement number 2, which says that angle number 1 is greater than angle 2. Statement number 3 says angle 1 is equal to angle 2. How come it possible that one angle is at a time equals and greater than any other angle? This is not possible. From these two, only one condition can be true at a time. So statement number 4 is statement 2 and 3 cannot be true simultaneously. They cannot be true at a time. Trichotomy property of order relation. Okay, this is the trichotomy property. It means angle number 1 is equals to angle number 2 is true because it is given, and this is we have assumed that angle number 1 is greater than angle number 2, so it may be wrong and the thing which is given, it will be correct. Hence angle 1 is equals to angle 2 is true and AB and CD do not intersect. Okay, our assumption is wrong. We have assumed that A and B intersect each other, which leads to an absurdity, which leads to an incorrect result. That is why our assumption is wrong. Our assumption was that the lines are not parallel. If it is wrong that lines are not parallel, so the right thing is lines are parallel, and that is what we have to prove. Sixth statement, or line AB is parallel to CD because they are coplanar and do not intersect. When they do not intersect, it means they are parallel. That's it for today. Thank you.